Hi everyone, Nas here from Info.Tech.Journal. In this particular journal entry, we'll be discussing two flavors of EIGRP, which is an interior gateway routing protocol by Cisco. The two flavors would be the Classic EIGRP and the Named EIGRP. There's a particular problem environment or problem scenario that we're trying to solve. In this particular scenario, we have one side of the network in the Classic EIGRP mode. Another side is going to be named EIGRP mode. Okay, for whatever reason, this is the environment that is this particular problem reared its ugly head. So we have a router here. Let's just say this is R2, R3, and it's connected to R1. Okay, it's connected to R1. So this is going to be a classic EIGRP. In the classic EIGRP, it is the older implementation. And what I mean by older, it might be in an older segment of the network where this particular newer device has been brought in to the network as an addition, and a different neo engineer might have configured it, or whatever the scenario might be, but then that is the current scenario we have. So R1 is configured in Named EIGRP, R2 and R3 is in Classic EIGRP. So in this particular segment, they have loopbacks. Okay, they have loopbacks. This might be connected to other routing protocols, or you might be redistributing static routes, some connected routes, probably OSPF, and so forth. Okay, you might be redistributing this into your EIGRP. When we redistribute it, this particular friend or this particular colleague found in the routing table, okay, you have a routing table. In R2 and R3, all this information that's been redistributed in EIGRP was present and visible in the routing table. However, when we put in EIGRP name mode, we verified that the neighborship was up. We saw that these information that's been redistributed were in the EIGRP topology. However, it was not in the routing table. It was not in the rib. So let's just try to recreate this in our lab and see how and why the problem occurs. So in this particular lab, we're going to do something quite simple. So in this lab, we'll have three routers. So three routers. So I'm gonna, okay, three routers. Okay. So we have router 1, router 2, router 3, R1, R2, and R3. Okay. Simple connections there. Basic IP addressing for this lab, we're gonna have the first octet as a 10, second octet as 0, XY meaning the number of the routers connected, usually with the smaller one first, and Z being the number of the router, and /24. So for instance, this particular link, it's gonna be 10.0.12.0/24. This side being 1, this side being a 2. This particular side is gonna be 10.0/.23-0.0/24. This is gonna be a .2. This is gonna be a .3. Again, we're gonna have loopbacks. This is loopback gonna be 1111/32. This is gonna be 2222/32, and this is a loopback gonna be 3333/32. Okay, that is what we're gonna do for a lab. Okay, and this particular lab, this side, okay, this side is gonna be running in Classic EIGRP, and this particular R1 is gonna be in named EIGRP. The first thing we're going to do is we're going to configure R2 and R3 because that's considered to be the legacy segment of the network. And we can see once we redistributed our connected interfaces, namely here, we're going to be redistributing our loopbacks into the EIGRP process. We're trying to keep it as simple as possible. We could have redistributed static routes or maybe have another routing protocol, maybe OSPF, and redistribute it in. But to get to the problem statement we're trying to solve and figure out, it's just simple to just have a simple loopback and redistribute it into our EIGRP process. So let's go into our network emulator. Okay, in our emulator we have here we're gonna have 3 routers, 1, 2, and 3. We're just gonna connect them directly. Oops, I don't like that. Oh, here I'm gonna delete this. It's a pet peeve of mine if I like to connect them with the same number. So you notice that one was 1 and 0. I like it to be 1 and 1. So we just keep it simple that way. Okay, now we have this in our network emulator, our JNS3 environment. Let's start it up and open the console. Okay, so this is a basic template that we have: router EIGRP 100, no auto, and so forth. We're not going to worry about that right now. We're just gonna assign the IP addresses. So let's see, router 3 is not up yet. Okay, router 3 is up. Okay. Okay, good. Router 3 is up. Okay, now let's just do a basic configuration. We're gonna go for this. So basic configuration, of course, we're gonna go into global configuration mode. And we're gonna do the interface E0/0. As you can see here, it's E0/0. Right. And then IP address, it's gonna be 10.0.12.1. Gonna be /24. That. And let's just go directly into interface. Look like 0. IP address. Okay, it's gonna be 1.1.1.1, 255.255.255.0. Okay, that's the basic IP addresses that we want. Okay, so we're just gonna copy this. We're going to go to R1, paste it in. Okay, let's just readjust this a bit so it's easier for us. Okay. Now let's go to R2. R2 is gonna be the same. So for E0/0, it's gonna be 12.2. Loopback is gonna be 2.2.2.2. Okay, and then we have an additional interface. The additional interface is E.1. It's gonna be 23.2. So 23 is for the 3rd octet. 4th octet is gonna be a 2. We're gonna copy this. Make sure we're in the console for R2, and we're gonna paste it in. Okay. Next thing you know, we're gonna go to R3. R3 has one interface, which is Ethernet 0/1, and this is gonna be a 3 for the 4th octet, and this is gonna be 3.3.3.3. And let's copy this. Make sure we're in the console for route 3, and paste it in. So a simple test we want to do is just to make sure that all the interfaces are up and it is reachable. So we're going to go to the central router, which is R2. From R2, we're just going to do a simple broadcast ping. Then we're going to wait a bit. That's going to ARP, address resolution, and then you will see a reply. Okay. Of course, you're not going to see a reply from the loopback since we don't have no routing information within the router itself. A router only knows what it is directly connected by default if there's no routing protocols or static routing. So now we know that from R2, the 2 interfaces are up. So The first part we're going to do is have our classic EIGRP in R2 and R3. So router EIGRP. Oh, let's just do it here. I'm going to do it for R2. Router EIGRP. We're going to have an autonomous system number. If you put in a word or a name, it's going to be a name mode. So we want it to be in classic mode. So let's just pick a number. Let's just pick 100. Okay. Here's a slight information for you. If you were basically the older CCNA or doing Cisco stuff for a while, you might remember that with router EIGRP, we always have a habit of saying no auto summary. After, if I do believe it's after iOS version 15, no auto summary is now a default, so it's no longer required. But out of habit, if you're just saying no auto summary, it's still good. But if you don't do it, if you see a junior engineer or network engineer that does not include auto summary with their EIGRPs, it's okay as well. Just make sure that it's iOS 15 and above. Okay, so we're gonna say that. We're gonna say network. Remember, we're gonna do this for name mode first. Sorry, I say again, classic mode for router 2 and router 3. Okay, it's gonna be network. So our network would be 10.0.23.0, and then you have your wildcard, which is 0.0.0.255. Just as a quick recap, 0.0.0.255, it basically means 0 has to match the first octet, second octet has to match 0, third octet has to match 23, the fourth octet, I don't mind what it is since it's 255. Of course, you can have a different value other than 255, but then that is not in the scope of the video. I'm just doing it simple just to recreate the problem with redistributing routes and it's the routes not being visible in the name EIGRP process. So we have this. We're going to say enter. I'm going to say do show run section EIGRP. So this is what we have. You notice that now the no auto summary is not visible because it's the default. You won't see the defaults. Okay, we're gonna go here. We're gonna go to R3. We're gonna wait a bit, and you will see we have form an adjacency. So just to verify, I say do show IP EIGRP neighbor, and I can see my neighbors. And then if you say do show IP route right now, you won't see anything. See, you just see C and L, of course, because if you look at the topology, show IP EIGRP topo, show IP EIGRP topology. You see here we've learned this, okay, connected. But then if it's learned via EIGRP, but you have a connected route, of course it's gonna prefer the connected route just because it is directly connected. Okay? It has to do with its distance and the connected routes going into your routing information base. But again, hopefully you have a basic understanding of what gets into your routing table when you're doing this video. Okay? Just so we have something visible, or just to mimic our problem statement or problem environment, we're gonna have R3 redistribute its static route. So let's go to R2. I'm gonna say show IP route. You don't see any of the static routes as well. And if I say show IP EIGRP topology, you don't see the loopback as well. So here, I'm gonna go again. I'm gonna go into my routing process, which is router EIGRP 100. I'm gonna say redistribute. Okay, connected, metric. Again, this is a habit. Have you been doing Cisco for a while or doing Cisco labs? When you redistribute for a particular instance or particular scenario, it's always gonna be like this: 1.1.1.1. Sorry, not 1.1. 1 space 1 space 1 space 1 space 1 1. If you're not too familiar with this, basically it has 5K values. The first K value is gonna be bandwidth. you're gonna say 1. The second k value is gonna be delay. Third is reliability. Fourth is your load, and the fifth is your MTU. This is what people have done for a while in labs, and I've also seen this in production networks, because this used to be not a major concern unless you were having different distribution. Unless you were distributing different types of information, like one for OSPF, one for connected, one for at a very convoluted or very complex redistribution point, then you will be a bit more particular. But if it's a one-to-one direct distribution, usually I see it, people just say 1 1 1 1 1. Okay, in labs and actual environments. So when you say this, you're gonna say that, and let's go to 2, and let's swipe it out. Now you see here you have D for EIGRP and EX for external. So I've learned this externally, and we see that 333, that is learned via EIGRP. So if we say show EIGRP topology, we can learn it here as well. So if you want more information about this, if you say question mark, you can see here what is the particular network you want. So for this one, we just say 3333/32. Sorry, not 32. That's actually /24. Okay. Yeah, /24. Interesting. Let's say it is a /24. Oh, sorry, it's not 3330. It's 3330/24. Okay, there you go. So now you can see here we have a feasible distance of, let's see, what is that? 333 100,000 million, 2,560,000,000, so forth for feasible distance. Okay, and our advertised distance and feasible distance here, since it's the only one, it will go into our routing table or routing information base. As you can see here, we do learn it here as well. So let's do it for R3 as well. Sorry. Let's go make the loopback on R2 visible to R3 as well. So let's just verify it first. To show IP route. As you can see here, it doesn't have 222 as presented. So we're gonna go here. Complete. Same thing. We're gonna go to our routing process, router EIGRP 100. We say redistribute connected matric. Go here. Open up. Now we have 2222. Also as well, since this particular link is also connected and it is not directly in the EIGRP process, of course we will also get that and redistribute it in. So you'll see this under DEX external. Once we actually include the interface in the process, EIGRP process, this will no longer be external. Okay, let's proceed next to the second part. We verified that the redistribution works, and the two classic EIGRP process running on R2 and R3 has successfully exchanged route information, and that particular loopback has been placed into our routing table. Okay, now let's go to R3. Oh, sorry, R1, and start the name version of EIGRP. So for R1, okay, we're gonna say router EIGRP. As you've seen previously, we have two options here. You can have the number, which is classic, or the name. So I'm just gonna say name. Okay, name. Okay, again, after that, if you know some basic information about Named EIGRP, you have to go into the address family. Address family, for this particular address family, is IPv4, and we will say autonomous system number. What is the autonomous system number? Again, just a quick refresher. If you're doing OSPF, the number after the OSPF process is just the process number. It's not, it doesn't have to match with every other router because it's locally significant. But for EIGRP, that particular number is your autonomous system number, and it has to match between all the routers that you want to be under the same autonomous system. And so here it's going to be 100. We're going to say network. What is our network? 10.0.12.0. And that's network. We're going to wait a bit and it's going to say nothing because we have not set it up on R2. So we've pretty much done on our R1. Let's go to R2. We say network 10.0.12.0. It's done there. Network, and we see that the adjacency is up. Okay, so if I do show IP EIGRP neighbor, and you see now R2 is now neighbor with R1 and R3. If we go to R3 and we say show IP route EIGRP, okay, not EIGRP, we just say show IP route. Okay, these are the routes. If you notice here now, this is no longer DEX because now it's directly under the EIGRP process. We're advertising it as such. So now the EX is missing, or not missing, it's been removed, as you can see here. And let's go back to router EIGRP. And you can also see here that it has learned that 10.0.12 it's now reachable from R3. Okay, let's go back to R2. I say do show IP route EIGRP. Okay, 3 is visible. 3 is visible as a EIGRP external route. So now let's go to R3. Let's go to R3. So now I'm in R3. If I say show IP EIGRP topology, you can see that R3 loops back and R2's loopback is visible. See? Because I'm in R3. So let's go to R2. I'm going to say show IP route. Sorry, not show IP route. Show IP EIGRP topology. You can also see that R2's loopback and R3 loopback is visible. Okay. Now let's redistribute 111 or loopback from R1 into EIGRP as well. Okay. So this is going to be topology based. It's going to be topology based. I'm going to say redistribute connected metric, same metric 1 1 5 1. Right. So here we didn't see that loopback. It was not advertised. If we do it again, you will see now it is being advertised as 1 1 1 1. If you go to R3, you can see 1 1 1 1. And if we go from the topology for EIGRP into our routing table, our routing information base, show IP route EIGRP, you can now see 1 1 1 1 in the routing table as an external route. So here is where the problem starts. If you go to R1, you would assume that since the topology from R2 and R3 seems to be converged well and dandy, that if you say show IP route EIGRP, you would see those routes in here as EIGRP externals, but somehow it is not present. It is not present. So you verify, is my neighborship up? So I say show IP EIGRP neighbors. I am neighbor to R2. That's correct. And my friend would do the same on R2, and I say show IP EIGRP neighbor. It is neighbored with R2, and I just verified the topology that is there. Oh, let's do it on R1 as well. Let's see the topology for EIGRP. Show IP EIGRP topology. You look, okay, you look at here. Oh, it's here, and it is present. But now you're wondering, why is it not in our routing table? Okay. If you're like me, when I looked at this, I usually just look at this particular part in the beginning, right? But then you notice the feasible distance here, even though we have a feasible distance here as a very big number, right? But the feasible distance here is being stated as infinity. Oh, what is infinity? So you dive a bit deeper. So you're going to say topology. Let's just say 22222. Sorry, 2220/24. Okay. FD is infinity, and this is the rib. routing information base, this is going to be the value that is going to be placed in. If you look at that value, it's 429, right? But the value here is a bit bigger. Okay, if you go back to, let's say, R3. Okay, if I say we do have this one, so let's just say show IP EIGRP topology 1.1.1.0 /4. If you notice here, FD, and there's no mention of your RIP's value, your RIP value. This is where it starts to get a bit funny, right? Why is this value mentioned here and not here, and this particular one has it as infinity? This is where you have to know a bit about EIGRP name. The difference between the two metric calculation with classic and named EIGRP, named EIGRP actually uses what we call EIGRP wide metric. EIGRP wide metric. If you read here a bit closer, okay, EIGRP wide metric supports 64 bits calculation, while classic mode supports 32-bit calculation. This 64-bit calculation, right, might cause problems when the value exceeds what is acceptable by your routing information base. Okay, when we were trying to troubleshoot this, okay, I stumbled upon this good article on LinkedIn. It's quite simple. Okay, EIGRP wide metrics and the 5-1 tricks. Okay, 5-1 tricks. Okay, by James Kelly. It's quite good. Probably have a quick read. This is what usually people do. Okay, especially for OSPF and labs. But this is where it gets a bit funny. EIGRP calculates its own topology metric and then sends it up to the actual rib. The rib value can hold this much, which is a 4-byte value. When the number gets a bit bigger, that's when you have the problem of that infinity. That means it cannot go into your routing information base, especially for what we did in our lab for named EIGRP. If you notice here, for named EIGRP, so run section EIGRP. Okay. We did this topology based redistribute connected 111. It accepted it, no problem. And when we go to R2 and R3, loop back 1111. Oops. Loopback 111 is actually visible. Okay, loopback 111 is actually visible. See, right? Because this value is not calculated with the wide metric value. You can go a bit deeper if you want, because the calculation is a bit complex. So the solution for this is actually quite simple. This is where habits could cause problems, and I would say I'm guilty of this as well. Sometimes it's just what the old senior engineer, network engineer used to do with redistribution. Oh yeah, you can just put 1111. It's not a big deal. And it just becomes one of those traditions or one of those habits that you actually put in. And it's in some of the documentations, if you read some of the older documentation as well for redistribution. Okay. So for this particular instance, we're gonna go to, and we're gonna just do a quick simple fix. The fix is not to move backwards. The fix is actually to change your metric to something a bit more feasible, not just 1111. So we're gonna go back to, let's say, R3. Okay. Route do show run section EIGRP. Then we're gonna go to the process, and for this one we're gonna say no. Go back here. So rather than saying 111, let's just say an actual value. Okay, let's say this actual value, that link is maybe it's 100 kilobytes, or no, 1 megabyte. Okay. So sorry there, I have to just close that real quick. Okay, let's just make this, it's in kilobytes. So 100,000 kilobytes, right? Something like that. So, and then we just say here, delay, I'm gonna say 1 because it's a very fast link. For example, reliability, it's gonna be 255 because it's 100% reliable. Load is gonna be 1, and MTU, of course, is gonna be 1500. So I'm gonna copy this. Okay, so let's just verify that real quick. We're gonna go to back here. We're gonna go on show IP EIGRP topology, and now you can see for the third loopback. Okay, you can see here for the third loopback, you can see now the value for feasible distance is no longer infinity, and this is a value that is acceptable by the routing information base, and it can go into our routing table. So if I search route EIGRP, now 333 is properly installed in the routing table. So we're going to do the same thing for R2. Okay, so router EIGRP 100. Okay, I'm just gonna paste it in. Oh, sorry, I'm just gonna do show run section EIGRP. No, I'm gonna go to R3, paste that in. Now we're gonna go show our show IP route EIGRP, and now 222 is also invisible because it's no longer infinity. So we're gonna fix it on R1 as well. Of course, R1, since it's still backwards compatible with the classic mode, you can still see it on R2 for that particular loopback. But then for consistency's sake, it's better just to change everything. So here, let's just make sure it's to show run section EIGRP. Go here, topology base. Oh, sorry. Topology base. I'm gonna say no here. And we go to R3. I'm gonna copy this and go back here. And if you notice just now, the value of R1 is this ridiculously big number. So if we say again, swipe it up, it is now smaller. Okay. Now that was the gotcha for using redistribute and with the seed value of 1111. Right, that's the problem. It might seem benign or simple because it is quite simple. It's but then when you're troubleshooting something, and if you're not aware of Named EIGRP having wide metrics and a value of infinity cannot be placed into your routing information base or be installed in your routing table, it is quite tricky. Okay, so that is basically our journal entry for today. We've looked at very quickly on Classic EIGRP, Named EIGRP, and the problems we can run with having a seed metric for redistribution. That is the comfort or the typical or what we usually do in labs, or in sometimes, for instance, in production networks where we have a seed metric of 11111. And this can run into problems when you have one flavor of Classic and another flavor of Named EIGRP, where one uses the Classic metrics calculation and another uses the wide metric calculation. Just a quick snippet there. Why did we introduce the wide metric? Wide metric is actually just to make sure that when we do the metric calculations for links that are above 1 gig to 10 gigs or 100 gig links, that we can actually differentiate between those speeds as well in terms of the metric value. If we use the classic metric calculations, when it goes to 1 gig, 10 gigs, 100 gigs, it doesn't really differentiate in terms of the advertised distance value, and this comes into problems when you're actually having to select one route for your primary route and having a secondary route for your feasible successor in terms of your FD and AD value. Okay. So that's the rationale why we had Cisco introduce this white matrix. If you're familiar with spanning tree protocol as well, and the T values and the expanded values for spanning tree, that's quite similar in terms of what it is. Okay, so that is it for this entry into my video journal. Hopefully it out there somebody is running through the same problems and you happen to find my video and it did help you. If it did, you can give me a thumbs up, maybe a subscribe, because I'm going to produce some random journal entries, whether it be programming, networking, and the likes. I hope you found this video helpful, and I would like to thank you for viewing. Have a good day.